Covering 2.7 using formulas. This is the last section of our chapter 2. So it says I can solve equations for specific variables and convert units of measures by applying the properties of equality. A formula is an equation that expresses a relationship between certain quantities. A formula or equation that involves several variables is called a literal equation. So here it says solve 5a minus 2b equals 15. So our goal is to isolate that a. So when I'm looking at this, I want to see what is the easiest to move away from a. So that 5a, it's attached through multiplication, so we want to move that 2b first. Now since it says minus 2b, we would add 2b to both sides. Now remember, one of the most important parts of this is you can only combine like terms. So the 2b's cancel. 15 and 2b are not like terms, so this would become 15 plus 2b. Okay. Then, to get a by itself, we got to get rid of that 5. Well, this is being multiplied by 5, so we would want to divide by 5. The 5's cancel, leaving us with a equals. Now, you could rewrite this as a fraction. So we could have 15 plus 2b over 5. But we could also rewrite this to where we're dividing each thing by 5. So we could have 15 over 5 plus 2 over 5b. Okay. 15 over 5 simplifies down to 3. So then I'd have plus 2/5 b. So this is the most simplified version of that equation when you solve for a. You also could have written it as 3 plus 2b over 5. That is also acceptable. And technically, this version over here would also be acceptable. It's just you didn't end up dividing each thing by 5. Okay. So this next one, example 2, we have 4p minus 7r equals pq plus 16. And it wants us to solve for p. So the first step for us is going to be getting our p's to the same side. So to get rid of this pq, I'm going to go ahead and subtract pq from both sides. Now, when we do that, 4p and the minus pq are not like terms because one has a q and one doesn't. And then they're not like terms with 7r. So we would leave that. Our pq's canceled and we got 16. Now we're trying to get p by itself, so I'm going to go ahead and move that r out of there. So I would add 7r to both sides. So then we get 4p minus pq equals 16 plus 7r. Now, quite a few people can get here, and then they're stuck because, like I said, 4p and pq are not like terms. But they both have p in common, which this relates to something we talked back in Unit 1, which is if they both have the same thing, you can pull that out using the distributive property. So I could pull p out, and that would make this 4 minus q, in parentheses, equals our 16 plus 7r. So I pulled the thing they had in common out. Now, p is being multiplied by something, so to get p by itself, I would divide by that 4 minus q. So we're left with p, because those 4 minus q's cancel. And then this, there's not really a simplified version to write it in. So our 16 plus 7r over 4 minus q would end up being our final answer. Okay. So it's going to be the process. You guys could have done the steps a little bit out of order, but no matter what, you should still arrive at the same answer. So like this problem, you could have started out with adding the 7r, then subtracting the PQ and going from there. So example 3, it wants us to solve the equation for part A, or the formula, and then part B wants us to plug in some measurements into that formula. So it says the area of a trapezoid is A equals H times B1 plus B2 over 2. A represents the area, H represents the height, B1 represents the length of one base, and B2 represents the length of the other base. Solve the formula for H. So they want us to solve for our height. Okay. So when I look at this equation, I'm going to rewrite it. So A equals H B1 plus B2 over 2. To start getting H by itself, I got to get rid of that 2 down there. Since it's being divided, I would multiply both sides by 2. So this gets me 2, capital A, equals H times B1 plus B2. Now, we're trying to get our H by itself, so multiplication is happening between H and those bases, so we would divide by those bases. So divide by the B1 plus B2, and what we do to one side, we do to the other. Okay, so those cancel, leaving us with our height, and then that becomes 2A, so 2 times our area divided by base 1 plus base 2. So that answers part A, solving for H. So part B wants us to use that to get an answer. So it says find the height, so we're finding H. The area, so our capital A is 70, and our bases are 22, so B1, and 18, so B2. So we had 2A over B1 plus B2 equaling our height. So we can plug our numbers in. So I would have 2 times my A, which was 70, over my bases being added, which were 22 plus 18. And that should get us our height. Well, 2 times 70 is 140. And then remember, our fraction bar is like grouping, so we can go ahead and add that denominator, which 22 plus 18 is 40. So this is what we have now. So then I would take 140 divided by 40, which gets me that our height would be 3.5, and then our units would be feet. So that would be the area, or not the area, the height for that trapezoid with that area in the bases. Okay. So this next one here says use literal equations. So we're going to go ahead. This one has 3 parts compared to the one we just did, which only had 2. Okay. So it says the total amount of money Keisha spends on pizza for a party is T equals $13.49 times C plus $15.49 times P. T represents the total cost of the money she spent. C represents the number of cheese pizzas she buys, and P represents the number of pepperoni pizzas she buys. If Keisha has, say, $85 to spend on pizza, describe the constraints on this equation. So, there are a few different things. First, she can't buy negative pizzas, so C and P can only have a minimum of 0. Okay, so C and P can have a min of 0 because you can't buy negative pizzas. Okay, so we know what the min is. So now we need to go through and find the max of each of these. So to find the maximum of cheese, that would be when you have no pepperoni. Okay, so you would want to take 85 divided by how much a cheese pizza is, which is 13.49, which gets you 6.30. So we have a max, and we can't go over this, so a max of 6 cheese with no pep. Okay? Because if we get more than that, we're going over the $85. So then we have to do the same thing to figure out how much pepperoni pizza we could buy. So I would take 85 divided by how much pepperoni is, which is 15.49, which gets me 5.49. So remember, we can't go over that, so we can get a max of 5 pep, but that's when we have no cheese. Okay. So those are our 3 constraints. We have the max of cheese we could get, the max of pepperoni we could get, and then the minimum of both of them. Okay. So B says solve this for C. So we want to go ahead and try and get our C by itself. So the first thing we want to do is get that P term to the other side. So we would subtract 15.49p from both sides. Remember, these aren't like terms, so we can't combine them. So I'd have t minus 15.49p equals 13.49c, and those 15s had canceled. Between the 13.49 and c is multiplication. So to undo multiplication, we would do division. So I would divide both sides by that. When we do that, we would have t minus 15.49p over 13.49, and that would equal our c because those 13.49s canceled. So right there is my solution for C. So then part C says if she has 85 to spend, so the total we have is 85, and she needs to buy 3 pepperoni pizzas, so our P is 3. They want us to find the maximum of cheese she could buy. Okay, so we know no matter what, it has to be between 0 and 6, because our min was 0, our maximum was 6. So we're going to go ahead and plug these numbers in. So we had T, which was 85, minus our 15.49 times P, which we just said is 3, divided by 13.49 equals our C, which is the amount of cheese pizzas. So if we multiply those two numbers, the 15.49 and 3, we're going to get $46.47 divided by 13.49 would equal our C. If we subtract those, we get $38.53, and we're dividing that by 13.49 to get our amount of cheese pizzas. When we divide that, we get that C is about 2.86. So this is the most amount of pizza that you could buy of cheese. So you can't buy 0.86 of a pizza, and if you buy 3, you've gone over your amount of money. So the maximum amount of cheese she could buy is 2. So we have a max of 2 cheese pizzas. And that is when she only has $85 to spend, and she's already planning on buying 3 pep. That means she can only has enough to buy 2 cheese. Okay. So we're going to go ahead and move on to that next one, which is going to have dimensional analysis. Okay. So I'll go ahead and read that to you. So when using formulas, you may want to use dimensional analysis. Dimensional analysis, or unit analysis, is the process of performing operations with units. As you plan your solution method, think about what units were given, what units you need for the solution, and the steps you need to take to convert your units from what you are given to what you will need for the solution. Okay? So in this first one, Mark is purchasing an above-ground swimming pool. The salesperson says that the pool will hold 97,285 liters of water. If 1 gallon is 3.785 liters, determine approximately how many gallons of water Mark's pool will hold. Okay, so we're given liters, but we want gallons. So there are a few different ways you could go about doing this. One way is to write a conversion factor string of multiplication. So you would take the thing we're given, which in this case is 97,285 liters, and you would multiply by some fraction, because technically this number is over 1. Okay? We're trying to get gallons, so we want our units to cancel out. So if there's liters on top here, we want liters on the bottom of our next fraction. Our answer we want in gallons, so we want gallons on top, and we would use that little conversion thing they gave us. So 1 gallon is 3.785 liters. Okay, so this would help us cancel out those liter units, leaving us only with gallons. When you guys learn to multiply fractions, you multiply straight across. Okay, the nice thing about this one is those numbers are 1. So on top we just have 97,285 gallons divided by, the bottom doesn't have units anymore, but 1 times that number is 3.785. So now this turns into just a regular division problem. When you divide these, you get about 25,703. So how many gallons of water will it hold? It's going to hold about 25,703 gallons. So we're going to get a few more complex unit conversions out of this to help us kind of see what it's like. So we have 2 examples left, and they do involve quite a bit of matching up these units to get us a little bit more practice. So the first one here, we have a recipe calls for 20 fluid ounces of milk. If Nita buys half a gallon of milk, how many batches of that recipe can she make? Hint, 8 fluid ounces equals 1 cup. Okay. So, we are starting out with the fact that we have half a gallon. Okay. So that's what we start out with. So we're starting out with gallons. Then we'd want to multiply it. We're trying to get down to fluid ounces. Okay. So we know at the end of this, we want to have just fluid ounces left. So we got to figure out what string of operations to do. So we know how many gallons or how many quarts are in a gallon. So we want gallons to disappear. So we put gallons on bottom, which makes us put quarts on top. Then we want quarts to disappear. I might have to erase and make a little bit more room. In quarts, we know how many pints there are. Okay. Then we want to get rid of pints. So we would multiply by pints on the bottom. And for pints, we know how many cups there are. And then we want cups gone. And for cups, we know how many fluid ounces that is. So this is the string of multiplication we need. So this gallon part is going to be over 1. Okay. So for our gallons, we know that we have 0.5 gallons of milk over 1 times. There are 4 quarts, which I'll just put Q, in 1 gallon. In 1 quart, there are 2 pints. In 1 pint, there are 2 cups. And then in 1 cup, there's 8 fluid ounces. Okay. So, when we look at this, the units that are on top and bottom would cancel out. So gallons cancels, quarts cancels, pint cancels, cup cancels, leaving us with the correct unit. When we talked about multiplying, we multiply directly across for fractions. So we'd be taking 0.5 times 4 times 2 times 2 times 8 fluid ounces over 1 times 1 times 1 times 1 times 1. So we know that'll be over 1. 0.5 times 4 is 2. 2 times 2 is 4. Times 2 is 8. Times 8 is 64. So this would get us 64 fluid ounces. Okay. Now, we know that a recipe uses 20 fluid ounces. So to figure out how many batches, we need to take our 64 fluid ounces over 1 times our fluid ounces for 1 batch, which was 20. Fluid ounces cancel, so we multiply across. So we'd have 64 over 20. 64 divided by 20 is about 3.2. Now we can't make 0.2 of a batch, so we only have enough for 3 batches. So that would be our answer for this one. So the next one here is going to be the same type of idea. We're going to have to use these strings of conversions to go ahead and convert this. So, speed. I'm just going to let you know, I don't know how to pronounce this word, so it says, in the novel, the main character, Aiko, can run long distances in 16.5 Kanjaku, per second. Carla knows that the Olympic record for running a marathon distance of 26.2 miles is about 126.5 minutes. She wonders if he could beat that record. If 1 Kanjaku equals 10 over 33 meters, how far could he run in miles in that amount of time? Okay, and it gives us some conversions. So there are actually 2 different types of conversions we'll need to do. One, we'll need to convert distance, because we need to convert this Kanjaku to miles. And we also need to convert our time, because one's in seconds and one is in minutes. Okay, so we're going to go ahead and do that. I'm going to go ahead and do distance first. So our distance here, we start out with the 16.5. I'm just going to put, over 1. Then we would multiply. We want our k to disappear. We know that one of those is 10 over 33 meters. So then we want meters to disappear, though, because we want our answer in miles. Well, 1 mile is about 1,609.344. Okay. So then we'd go ahead and multiply this. Our units cancel out here, so that we have miles, and that is going to be in seconds, because that's what the original measurement was per second. So we're going to be taking 16.5 times 10 over 33, and then dividing it by 1,609.344. Um, if we multiply those two, we are going to go ahead, 16.5 times 10 over to 33 is going to get us 5. So this would be 5 miles in that many seconds. So 1,609.344 seconds. Okay. Now we can use that to convert our time. Okay. So we rewrite that of 5 miles over 1,609.344 seconds. For our time, we are trying to convert seconds to minutes. So we would multiply. Seconds was on bottom, so we'd put it on top this time. So seconds, there's 60 seconds in 1 minute. So our seconds will cancel out. So we would have 5 times 60 for our miles over 1,609.344 for our minutes. Okay. So we're going to go ahead and simplify this out. So if we take 5 times 60, that is going to get us 300. So we have that they can do 300 miles in 1,609.344 minutes. So now our job is going to be to see how far he can actually run in this time. Okay, so we're going to be taking distance, and it equals our rate times the amount of time. Okay, so we're trying to figure out how much distance they cover going at this rate. So 300 miles over 1,609.344 minutes. And then we'd multiply by the amount of time. So the amount of time it says is that it took them 126.5 minutes. Okay, so that's what we'd multiply this by. So we're going to go ahead and see how this turns out. So our minutes would cancel. To remember, this would technically be over a 1. So when we do this, we're going to have 300 times 126.5 divided by 1,609.344. If we multiply those two numbers, that is 37,950 divided by 1,609.344, which comes out to be about 23.58. So if we are thinking about this in terms of how they had it, which was 26.2, I would round this to 23.6. So they want to know if they would beat the record. Well, the record was running in this amount of time. They accomplished 26.2 miles. This guy only runs 23.6, so he will not beat the record. And the reason would be because 23.6 is less than the 26.2 miles. Okay. So that is it for the 2.7 notes. And then the last part that I have in the notes is just a summary of the entire unit.